Okay, hey everybody, welcome back. In the next series of videos, we are going to be talking about polar coordinates, one of our last major topics that we want to talk about this semester. And so when it comes to polar coordinates, these are a new way to describe points in the XY plane without using sort of our standard X, Y coordinates, but instead some new coordinates, which we'll call polar. Our goals over the next few videos are to learn how we can describe different points in the plane by either using its regular coordinates, what we'll ultimately see are called Cartesian coordinates, or polar coordinates, and be able to translate between the two. We'll also be interested in identifying some interesting ways in which polar coordinates have a sense of non-uniqueness and how we come to terms with that. And then I think not necessarily in these videos, but in the class period, we will be able to describe some curves that are described in polar coordinates. So let's get into it. This first video, I just want us to begin thinking about coordinates, what they are, how we use them to describe points, and how we might adjust them. And that will pave the way for polar coordinates down the road. So coordinate systems give us ways to describe the location of points in space. And typically, if we are describing points in a two-dimensional plane, we will need two coordinates to describe these. And our standard way of doing this, which has been sort of ingrained in us since we were young, is to look at the points in terms of the rectangular or the Cartesian coordinates. And so the way that this works, maybe first of all, to go down a dimension, so not looking at two-dimensional space, but just looking at a one-dimensional line. Well, in one dimension, we have sort of this picture, right? This is one-dimensional. We have just the one-dimensional real number line, and we can describe a point on this line by doing the following, right? We identify a special point, which we'll call the origin, right? And we'll identify that with the number 0. And then every point on the real number line is described by discussing how far away it is to the from the origin and whether it is to the right or to the left of the origin, right? So sort of making explicit something that you sort of understand at a very intuitive level. I can sort of mark off different points on this number line. And so if I wanted to talk about, say, the number pi, I would be describing the point that is pi units above the origin or to the right of the origin. And so I could identify that number with the point on the number line, right, or the point on this one-dimensional space. So that's one dimension. For two-dimensional space, we'll need two coordinates, right? And the way that we typically envision two-dimensional space, so here's two-dimensional space, right? We typically envision it by creating two different one-dimensional number lines, so two different real number lines that meet at 90 degree angles, so they're perpendicular to each other, and we call those the axes, right? And so this is the x-axis, and this up here is the y-axis. And in doing so, what we're really doing is we're singling out a special point, just like we did before, and that special point will be the origin. And it is going to be the point that corresponds to the origin along our x-axis and also the origin along our y-axis. And so if I wanted to describe a point in this space, say the point right here, I could do this as follows. I could measure out how far in the x direction, right? So I could measure out in this way, and I could measure out in this way. And I could say that in order to get to this point in two-dimensional space, I had to walk 1 unit up in the x direction and then 1 unit up in the y direction, right? Again, these two lines are perpendicular to each other, so it's unambiguous how I could get to this point. And so that corresponds to the 1 on the x-axis, the 1 on the y-axis, and so we would describe this as the point 1, 1. Again, this is something that everybody here knows and knows intuitively, but I just want to explicitly point out how we are sort of building up our intuition of two-dimensional space from our intuition on one-dimensional space, right? So we're adjusting these one-dimensional lines, these axes, in a perpendicular manner, and I'm describing how I can get to my point by going out in first the x direction and then in the y direction. And so these this pairing, this 1, 1, is the Cartesian coordinate, or I guess these are the two Cartesian coordinates that describe this point right here. And so when I say Cartesian coordinates, I'll sort of use the phrase rectangular and Cartesian interchangeably, right? Rectangular because I'm sort of describing, or I can associate with each point and each sort of pair of coordinates a nice rectangle, right? So this is sort of this nice rectangle right here. It's called Cartesian coordinates because it's named after a French mathematician who went by Descartes, last name of Descartes. And so this is the same individual who sort of created this sense of coordinate systems, or at least who first effectively used them and popularized them. For example, using coordinates to describe different shapes like the circle, or different lines. This is the same Descartes, I should say, who had the I think, therefore I am phrase, right? So a mathematician slash philosopher known for many things, and this is the Cartesian coordinate system, which he's named for. However, there are other coordinate systems that exist, and we will be discussing one of those in our next video. This is the polar coordinate system. In short, if I'm describing a point in two-dimensional space, what I really need are two pieces of information to identify a point. Here in this rectangular coordinate system, I needed the amount of distance that I traveled in the x direction and the amount of distance that I traveled in the y direction. In polar coordinates, we will actually use slightly different information. So specifically in polar coordinates, I will be interested in two pieces of information. I will be interested in the length of that line right there, so the length from the origin to the point in question, and excuse me, and I will be interested in this angle, the angle that's made from the positive x direction up to the point in question. So we could call that distance there r. We could call this distance here theta. And so instead of describing this point using the coordinate 1, 1, I could describe this point by identifying the distance r and the angle theta that it made. So we'll explicitly see how to do this in the next video, and then we'll begin to see the relationship between Cartesian coordinates and these new polar coordinates. So see you next time.